What are we looking at here? So this is a MOKO branded, which I've never heard of, a 150 watt car inverter. It's meant to fit in like a cup holder. So you'd hook up the lighter plug into like your cigarette socket or the power outlet, whatever it is you got in the car. And then you have one 110 volt outlet. It says it claims 150 watts. I haven't actually tried it for myself. I don't know how it actually works. This is actually a Christmas present. There's still like a little piece of paper left over right here that I didn't quite pull off. And it also has 4 USB ports. It's got 2 that say they're 1 amp. It's got 2 that are saying that they're 2.1 amp. It's got a little LED display like right in the center, little segment ones. So I thought we would open it up, take a look, maybe do a little bit of testing and see what it actually is capable of handling. So let's get started. Okay, so inside the box, it comes in a nice little bag. Pops out. There's not much else in there. You can see just the little cutouts. Oh, and here's the instructions. See if there's anything funny in here. So let's see. It's got the specs right here. It's got a modified sine wave output. Tells you like, you know, just some basic operation. Make sure you turn on your car. Oh, that's interesting. It says down here that when there's no load on the USB, all it displays is the input DC voltage, but when you have a USB device connected, then it'll display the load, the current value. We're gonna have to check that, see if it does that or not. Well, here's some pretty good life advice. Get away from the scene of moist. Easy combustion and explosion. No, that's about it here. Not a whole lot of interesting stuff. Alright, so there is the actual thing, and there's the plug. As you can see, there are no switches on this thing, so once it's plugged in, if you have the type of outlet where it's constantly on, then you know this thing's just going to drain the battery. Alright, so yeah, it all looks pretty much like it did in the box. This little slot up here is supposed to be like a card holder, so you would put like your cards there, I guess. I don't know if you'd want to risk like putting some cards in there, forgetting that they're in the car, and you know someone tries to break in or whatever. But yeah, this thing is not going to be able to handle 150 watts, but that's okay. I think it goes up to 6. I think that's what the 6 means in the model number here. And supposedly it outputs 13.2 volts DC. This is the back power connectors, but it's the same going to the socket right here in the front. So let's go ahead and turn this on. And we're going to plug that in. And it shows us a voltage. It just says 10. I guess it takes a little bit for it to actually read the actual value. Would be saying, okay, there it goes, 13.1. So about close enough to what this thing's supposedly outputting. I haven't measured it, so I don't know what the exact value is. But now that we're showing something here, let's plug in something to one of the USBs and see if it shows that current that it was talking about. Here's a Pi board with, we're not going to attach anything else to it. Let's just see what this thing says. So let's hook it up to the 2.1 amp output, and we'll plug it into the Pi. And it still just shows a voltage here. I mean, oh, there it goes. So according to this, it's pulling about 200 milliamps at the point, or 300 now. Actually, you know, we could check that. I'm going to use this thing. We'll compare against that. Now we've got the Pi connected to this little USB tester. Let's plug it back in. See what it says. Boy, that might be hard to see. Well, it's like super dim, but it's saying, I don't know if you're going to be able to see it right there. It's saying 0.33 amps, 5.18. Boy, that's terrible. Let me turn off this light here. Let me see that. Okay, that helps a little bit. So 5.18. So that seems to work. Let's see, does that work on every port? Yep, so it took a second, but it finally switched over here. So yeah, it shows about the same. Does it increase, or if we measure more than one, or hook up more than one thing here? So I'm going to hook up another cable, and I'm going to plug that into my phone. Whoops. Always got to turn the USB port around at least once, right? Before you get it in the right orientation. And it's charging now. So yep, now it went up to 1.7. And if we disconnect the Pi, let's see if it drops down by that 300 milliamps. So we'd expect to see 1.4, and sure enough, it did. let's try plugging something into the outlet and seeing if this value goes up, because I have no idea if it does or not. I'm kind of interested in that now. I'm just going to plug in this power supply for a laptop into that outlet. It's not connected to the laptop itself because I don't want it to draw too much power, because like I said, this power supply here is not like crazy powerful or anything. Once I actually try to do a test with the outlet with more current, I'll hook it up to a bigger power supply. But for now, I just want to see what this does. I want to see if this actually increases when we plug this thing in. And I guess not. Okay, so I guess this thing is only monitoring the USB ports, not the actual outlet. And if I unplug these, I don't think it's going to make a difference. Yeah, no, see, it just went back up to 13 volts. So it is, I can hear buzzing in the power supply, so it is outputting something. And because it's that modified square wave, you can kind of hear it, that it's not like a consistent like 60 hertz buzz or anything coming out of any of the components. So yeah, the fact that it measures the current on there from all the USB ports, that's kind of neat. And I mean, this thing is like really light, so I'm really curious to see like what's inside of it, how it's built. Many years ago, I actually had a like 100-watt inverter that you would plug straight into the cigarette socket. Some of you may have seen those before, and it was like 100-watt, and it was fairly like heavy, and it was kind of big. And for this thing to have like, you know, all these USBs, they're doing like a lot of, you know, they're going to have like a lot of really small components in there. A lot of surface mount stuff probably. That other one, it was like a lot of through-hole components, you know, like big TO220 MOSFETs and stuff like that. And it's even got this little fan. It's like really silent. Like you can barely hear that fan running when it's just sitting there. So it's not going to be sitting in your cup holder or anything, like being all noisy. Alright, so we got a few screws down here at the bottom. Looks like these two right here pretty much release the bottom cover. It's got two screws right there that look like they hold the fan in place. It looks like we should be able to slide this out through the front, because it looks like this front here detaches. So these two screws here are probably like holding, you know, something in there, allowing this thing to slide out. I'm not sure if we're going to have to remove the fan screws as well. I don't know if the fan's going to interfere with like pulling the thing out. I don't think so, just because it is wider at the top than at the bottom. So I would think that maybe the fan would just... Oh wait, but the fan is attached to this bottom lid, so... Oh, it's raining today, and it's coming down quite a bit at this moment. Not going to be able to hear it, but yeah, it's getting kind of heavy. Alright, now the fan's free. Actually, the fan's a little too free. It's just kind of in there now. I don't know how I'm going to screw it back on. I guess I'll figure that out when the time comes to that. Does this slide off? And it's not sliding out. And this is actually, feels like a metal plate. I thought it was plastic, but I guess it's actually metal. Okay, there it goes. I just had to pry it out a bit, and that's going to allow me to put this fan back onto that plate. And the fan's not coming out. Come on, fan. There we go. Oh, the fan can be unplugged from there apparently. So that's interesting. These screws, or these holes right here that this plate was screwed onto, they don't actually hold that board in place, but we can see a bunch of the components in there already. We do have some TO220 devices there, and surprisingly, they have no heatsink on them. So this whole thing is relying on being cooled by this fan pulling the air out the bottom, because that's the direction that the fan's actually blowing in. It's sitting like this. And these fans, they always kind of blow towards the back. Now, how do we get this out? Okay, there are screws that are hiding underneath this label. So, looks like I've got to peel this off. There's two up here, and it looks like there's two like right here. Hoping I can do it with this flat blade. Just gonna stick it in here in the edge and try to pry up on it. There it goes. It's coming up. Trying to be careful not to jab this into my finger or anything like that. There we go. Start seeing the screws. I think a little bit of heat would have helped here. That's pretty much all I need to do up on the top to get these screws out. I'll worry about the bottom section in a second. I'm going to hit these corners with a little bit of heat just to soften it up a little bit. Then maybe I can peel it up a little bit easier. It helped a little bit. There we go. Okay, there we go. So this outlet is actually a separate device, or like a separate connector from the rest of the casing. As you can see there, I can separate it. So this looks like it would pop up by itself. The plug is technically upside down compared to like some of the other ones we'd see in around the house. So I guess we could see if it can be flipped over or not. But now that I've got those screws out, this does feel like it's separating. So it's popping out. Ah, crap. I think I just broke the warranty seal, if that's what it was. Actually, it looks more like it's a quality check label right there, so no biggie either way. Now this whole thing just sort of slides out. Here's our cup. We can seal the bottom, and then we can use this for drinks or whatever. No, I don't recommend doing that. Oh man, I already see something funky with this. Okay, so we've got the outlet. We've got this one would normally be like the neutral in a house. This one would be the live, and that would be the ground. Check it out. No ground. Yeah, no grounding of any sort. So here's the connector there. It's like really thin gauge wire. And yeah, it looks, oh no, you couldn't flip this over because of the fact that it's actually cut out. So, well, I guess technically you could if you like were to cut the other side out or whatever. You could probably, and you'd have to cut both sides out, make sure that, you know, this thing would fit. But yeah, they made it so that it basically only fits in one direction, just like that. Not much else to see here. And this is the interesting part. This is where everything happens. It actually looks fairly nice. Board does not look bad at all, except for like some of that crustiness they left right there from the soldering. Funnily enough, this side here looks super clean. That side here looks like it's not terrible. It's just flux residue. But it's like they didn't even bother over here. I wonder why. Maybe this thing was, you know, kind of like wave soldered or something, and this side didn't solder properly or something. I don't know. This would have been done like after the fact, just because of how those leads are there. There's like nothing to hold this display, you know, to the board otherwise. There is a fuse in here. They've got a 25 amp fuse. Even this thing has a fuse. Unlike those, what were they? The Weller soldering stations that had no fuse on the mains. This would be the input cap. Here is our input. You can see that it's soldered directly to the board, the positive and the negative. This is where the FU goes connected. Fan unit. These right here, they look like they were designed to have some sort of heat sink right there. But instead of what they did is they have this bent aluminum plate with all these holes there. I mean, the holes would definitely help with some of the heat dissipation. And like we do have, like, you know, the air kind of flowing in like in this direction. So I mean, it is going to keep them cool. These, I'm guessing, must be just diodes. Oh, no. Sorry, not diodes. These would be MOSFETs. These are the ones that are doing the high voltage switching. So these two here would be switching the primary side on the transformer, which is right in there. And then these would be the H bridge for the 110 volt output. And it looks like the rectifier for the output is that section there. And then looks like we've got two separate switching supplies here for the USB. So that would be like one switching supply, that'd be the other one for that USB output. Those big resistors down there, looks like they might be the current sense resistors for each port. I don't know if they have like individual 5 volt lines going to, you know, each one of the two ports on each side. This is a bit wonky right there. Look at how that capacitor is just kind of off to the side, when this one here is like completely flat. It didn't look like there was anything there that, and actually, you know what, maybe it did. Maybe it's because of the, yeah, maybe it's because of the outlet there, because this thing went like this. Actually, even then, it doesn't look like it would hit. It looks like it's got plenty of room to stand up. So, yeah, I don't know why they did that. Maybe they were just trying to play it safe. Either way, it doesn't look like it would have mattered much. If we take a look at the bottom, we can see how this transformer is wired. It's actually very simple. So we've got the positive coming in, going through the fuse. The other side of the fuse comes out. It goes to that capacitor there. And the negative here is just this whole plane right there, basically. It goes to the source of both of these MOSFETs. And then the drain is connected to each winding of the primary on the transformer. We can see that the positive just comes straight into here into these two center pins. So basically what's happening here is the switching chip, which is this one right here, it's an MT494. So I'm pretty sure that's going to be like a TL494 switching controller, is switching each of these MOSFETs on and off. So it's taking, it's just basically going back and forth, back and forth, back and forth, get that magnetic field going there in the transformer. Then the output of the transformer, which is this side here, we've got two pins, this one and this one. These two are not actual, they're soldered there, but there's nothing there. I don't think there's any pins on that transformer on that side. No, I can kind of see in there. I can see that there's a wire going to like the pin. It's going to be hard to see here on camera, but like inside of there. So yeah, there's one of the windings from the transformer. There's only one winding and it goes to both of these pins here, and then that goes to the rectifier section, which is this full bridge rectifier section right at that point there. So we've got our positive and our negative that come out of these two spots here. That goes to our capacitor here. That's that smoothing capacitor up there at the top. So we've got our, this one here would be our positive side. Yeah, that would be positive right there. This is our negative side, and we can see here that the positive goes to these two MOSFETs right here. These are going to be all N-type MOSFETs, and what the number on those? Those are FHP 630. So yeah, they're all going to be identical. So we've got the positive going to the two drains on these two MOSFETs, and then the negative side is going through here. It goes up through these vias. There is a large chip resistor up there. It's probably going to be for current measurement, I would think. And then that goes up to the top here. You can see there's a fairly beefy trace there. It goes to the source of both of these MOSFETs here. And then the source of this MOSFET goes connected to the drain of that MOSFET. That goes to a, looks like a MOV right there. So that's going to be doing like some current limiting, I would think. And then that goes to one of the outputs. The other output, it goes to the drain on that MOSFET, and it goes to the source on this MOSFET. So it's basically just taking turns, like making each one of these, like positive and negative per the like modified sine wave signal. But this here is most likely not being controlled by that chip. That's going to be done with something else, and I'm not sure if it would be this one. No, this one here looks like it's doing the driving of this display. I don't see any other ICs on the thing. They might still be doing it with this one here. I haven't like traced out anything, but this here is probably like a microcontroller, so they're using it to both do the driving of the display, and also maybe some of these pins might be like going over here and controlling the switching on these, because they require like a pretty specific sequence, and I really doubt that they probably built it into that one if this one's just doing the switching for the transformer. We got a little 5-volt regulator right here, 78L05. So as far as these USB ports go, they did separate them. These are not connected, like bridged or anything. This is the ground side right there, so you can see that the ground is connected to ground as well as over here on this one. But each of the 5-volt ones has its own separate resistor here that it goes to, so that's how they would be measuring the current on all of each individual port. And that's pretty much going to be done with this thing as well. So yeah, I mean, I don't know what microcontroller this would actually be. It might be something that's just been like rebranded. I'll do a quick search and see if this MT372-XS brings up anything, although I kind of doubt it, but let's check. Yeah, no, that was a no-go. Brought absolutely nothing up that wasn't related to something else. Well, yeah, like I said, everything here looks, I mean, it's other than the fact that there's like no cooling here and these things are just kind of like flapping around. It would have been nicer if they would have like actually put something here, to keep these like secure. So, I mean, because this is going, it was meant to be used in a vehicle, and there's going to be vibrations, and vibrations and these things just, over time, they're just probably going to break off the board. So that would be no good. These, while not exactly, you know, all that great, I think it would have been better if they would have actually used like a heatsink here. And it looks like they might have even designed it to have like a hole right there, possibly to secure it from the opposite side, but it doesn't look like they allowed any sort of a pad or anything for that. But that would have probably been, you know, like the better way to go. Although, you know, they are secured here with this silicone material that they've used as adhesive. These still do vibrate around a bit, as you can see right there. So longevity in these, I don't know. It would be certainly better than these, but probably not as great as having their own like dedicated solution. I'm thinking this was probably a lot cheaper to do than getting these heat sinks. So other than those two things, that and this, I don't really see like anything all that bad about this design. Of course, I'm also not a pro or anything, so this is just based on like, you know, my opinion. This LED display here, also not the most secure thing because of the fact that it's just basically only supported by those pins. So over time, you know, that might crack as well, although it is meant to go inside of that rectangular cutout right there, but I don't know how snug it actually fits into that. Let's see. It's actually not too bad. It actually fits in pretty close right there, so vibration is probably going to be kept at a minimum on that, so that's good. I think this right here might actually be a thermistor. Not entirely sure, but it looks like this fan actually does have a transistor that controls it, so I'm wondering if this gets warm, like this area gets warm, if the fan will spin up. So what I'm thinking of doing is I'll connect the fan, apply power, and I'll use the hot air station and I'll heat up this area and see if the fan actually starts spinning faster. Okay, and just because I'm going to have a little bit of high voltage over here out now on the output, I just got to be careful not to touch any of this. And let's hook this up. There goes, the fan starts spinning immediately. Interestingly, there's two white LEDs on the front, but when the cover is on, you really only see this one here because this one's like completely blocked. But there's a secondary LED right behind this white LED right there. So I don't know what that's about. Maybe like if it gets overloaded or something, it'll flash red or it turns red or something. That's my guess. But now let's take the hot air station and let's see if this fan spins up if I warm up this area here. Yep, the fan's getting faster. Yep. I guess that's kind of cool. They actually put a little bit of thermal management into the thing. At first I thought they were just relying on the little bit that this fan spins to cool down the thing, and like I said, it runs very, very quiet. And yeah, I bet you can't hear this. Not unless I like put it like straight up to the microphone, but it's very silent because it's really not spinning like super fast. On the outlet it says 110 volts, but the voltage at the capacitor coming out of the rectifier is usually higher. So let's see what that measures. And we have our negative over on this side, we got a positive over here. So that's 150 volts right there. I was trying to find something a little more suitable for this, but let's start off with this 60 watt bulb for now. See how it does. And I also got the little thermal cam out. We can see like, you know, what areas in the board get like the warmest, or you know, what gets the hottest. 60 watt bulb, I'm kind of hoping that this will be able to handle it. If not, I'll have to step up to another supply. But let's just give it a shot real quick here. So the lamp is off. I'm gonna plug that in. This thing's gonna kick on. Okay, and now let's turn the lamp on. Okay, that took a while, but as you can see, it finally got up to kind of bright there. So that's not exactly the greatest, but I'm wondering if it's, like I said, I wonder if it's got to do with this power supply as well, because it's only up to 6 amps. And we can see that the voltage on here dropped when I turned the lamp on. It probably just has to do with this power supply not being able to handle a sudden load like that. Yeah, no, see, it flickered right just now. But once it warms up enough and it doesn't pull as much current from that supply, then it'll come on like fairly instantly. So yeah, I think right now I'm being limited by this power supply. So let me rig something else up and then we will try it again. I have this hooked up now to a 35 amp regulated supply, which should be more than enough to handle pretty much anything we can throw at it up to 150 watts. So like this lamp here by itself should not be a problem now. And I'm going to turn on the supply, and it's not plugged in. Okay, now we're playing with power. And I also decided to bring this thing out, and we can click on the wattage and see what it's pulling. It's really, if you saw that video where I tried to calibrate this stupid thing with like, you know, trying to thin out a piece of wire, it's really still not accurate. It's really not accurate at like really high wattages. That's lower stuff, it's kind of okay. Like this should probably be fairly close, it should work. But I noticed that when I was trying to measure some stuff that was like, you know, the several hundreds range or higher, then this thing just was not accurate at all. It was like way off. So for small stuff like this, I can kind of use it. Other things, not so much. But anyway, so let's turn on the power supply. And we're gonna get up here. And I can see that I got 13.5 volts about there. So I'm gonna turn it down just a tad. We're gonna go to 13.4, sounds pretty good. Actually, nah, this thing is like, this little knob is not very, well, the pot is not very stable. But whatever, 13.3, whatever. So it's saying about 116 volts or so right now, and we have nothing on. We don't have the lamp on. Let's go and turn the lamp on, and as you see, it came on right away. That voltage is actually not fluctuating very much, about 116, so it's staying about there. So let's hit the wattage button here and see what it says. So about 55, almost 56 watts according to this thing. So I'm going to let it run for a second there, and I'll pull out the thermal camera and we'll see what on the board here is getting warm. So one of the things that's getting fairly warm inside there is that mauve. I don't know how hot it actually, well, it's saying about, it's in the 60s or 70s according to this thing, but we also don't really have much airflow because the fan's like sitting outside here. Well, normally the air would be kind of like, you know, flowing past it. There's like another little warm spot down there, that little 5-volt linear regulator. Nothing else is all that warm that we can see. Looks like that little transistor driving the fan is a little warm, but I mean, it's not like crazy. These MOSFETs don't look like they're getting very warm at all. The rectifier section actually is a little bit warmer than the MOSFETs. So at about 60 watts, there's not much heat buildup inside of this thing. Let's try with about 140 watts. This soldering iron here, this is an 80 watt unit. And then we got the light bulb there that's supposed to be about 60 watts. So I got those two hooked up to this splitter adapter here, and I'm gonna plug that in. Right now it's still on. Let that run for a sec and then we'll see how warm things get. So here we go, and let's turn that on. So it came on right away. So the voltage at the plug here dropped a little bit, 12.6. You can see that that transformer is actually getting a little bit warmer now. It's actually been sitting for a while, so it's probably just been getting warm on its own anyway. Those MOSFETs are actually still running pretty cool on the output. So like I said, even without necessarily having to have a heat sink, it would have been nice if they would have just, like, you know, put something there just to prevent them from breaking due to vibrations later on. You can see that the diode bridge right there is actually, and this battery's almost dead. I just realized it's flashing. So yeah, those diodes are actually getting quite warm. That mauve down there, that one's it is pretty toasty. So it is starting to develop quite a bit of heat. This fan is actually spinning pretty fast right now. Oh, and according to this thing, we've got about 125 watts. Probably not that accurate. Kind of gives us a kind of like a ballpark of where it's at. One thing I hadn't really thought about, but that transformer is getting pretty warm now. And these two MOSFETs that are over here, the ones that do the switching, I mean, they're going to get warm too. So basically, the heat from the transformer is coupled to these MOSFETs through like that, you know, the adhesive up here at the top, and like vice versa. So they're both going to kind of get hot together there no matter what. So that would be, you know, maybe another argument for having individual heat sinks here for these MOSFETs instead of having these heat sinks glued on to the transformer the way they did. Let's put the thing together And I'll see if I can find something else I can plug into this to try to get the total about 150 watts, and we'll see how it holds up having its own little cooling fan pulling the air through it. So let's go ahead and put it together. Should be fairly straightforward again. Okay, so it's back together. So now it should have adequate cooling. Since we're technically only like 10 watts short with the 60 and the 80, I'm just gonna hook this 16 watt bulb up to my little overhead lamp here, and we'll plug that into here, and we'll try and see what this thing does. We'll let it run for a bit. Okay, we've got everything hooked up. I've got all three things plugged into the kilowatt. We see we got 13.5 according to this thing, 13.6 here. So let's just plug everything in at once. Everything should be on, and we'll see what it does. It's kind of bummer we can't really see the display there. The voltage according to this display is dropped to 12.3. This says 12.6 over here, and it's chugging along. This light's on, this bulb is still on, the soldering iron is heating up. Still about 116 volts. It kind of goes up and down a little bit there. The wattage, it says about 142 watts, 130. Well, it's fluctuating a bit. Might be its own regulation here doing something. So, but yeah, the air does feel a little warm. It's not like really hot. You can just tell it's noticeably warm. But then again, the transformer was already kind of warm to begin with. This has been running for a few minutes now, and the soldering iron has actually gotten hot enough to melt solder, so it's holding up. The air coming out of the back it still feels warm. Like I said, it's not like crazy warm. You can feel the air getting pulled in through those vents. 139, so it says about 140. I'm gonna swap the lamp out up here. I'm gonna put in a 27 watt CFL, and that'll raise the wattage a little bit. Let's see how that holds up. And we're gonna pop this into the lamp fixture, 27 watt. Okay, so now we've got this 27 watt CFL up there. Let's plug this back in. And everything is back on. What does this say? It's about 116 volts. Supposedly, according to this, we're close to that 150 now. Actually, as the lamp warms up, it's probably going to pull a little bit more because it is a CFL. So it's going, and it is rising. 146. Oh, I actually just felt the fan on this thing spin up. There is a lot of humming coming from that CFL. Whoa, yeah, 149 there. This has been running for quite a few minutes now, and the voltage is still at about 116. Wattage says 143 right now. Let's see what this thing says for amperage. About between like 1.3 and 1.4. But like I also said, this thing's probably not super accurate anymore since I messed with it. The voltage should be fairly okay because that doesn't rely on the shunt. Let's see what it says for hertz. 60.1. What about power factor? I don't know how accurate that actually is on this thing. But anyways, it's holding up. I don't smell anything funky. Seems to be fairly okay. This wire's getting warm though. Yeah, that wire's getting warm. And these terminals here are pretty warm too, so it's pulling quite a bit of current. Then again, alligator clips are probably not the best thing to be hooking this thing up with. It was just so I could do something really, really fast. But like this cable is getting kind of hot, and I'm doing this a little after everything. But I wanted to see how much current this thing pulls from the cigarette lighter socket. I've got it just to measure the amperage here. As we can see right now, just sitting idle, it's pulling just under 300 milliamps. And I'm going to plug in all three things again: the soldering iron, that light bulb, and then the CFL. And let's see what it does. 13.5, and it's going up a little bit. I'm gonna let it run for a few minutes and we'll see what it ends up at. All right, it's been a few minutes. It's kind of like settled off at about 13.5, 13.6 or so, and it just kind of keeps fluctuating up and down there. All the wiring is quite noticeably warm. It's not like hot to the point where I can't keep my hands on it, but it is quite warm. And check it out. So this right here, and where's it at? Right down here. That is the wiring going into the inverter. You can see it's a lot warmer than my hand. So yeah, everything's getting pretty toasty. So this is not something that you would want to load up with something like this, you know, like anywhere even close to like 150 watts and keep it continuously running there for a long period of time, because things are gonna get pretty toasty. And a lot of car fuses are only rated sometime or somewhere like between like 15 and like 20 amps or so, but the socket is not meant to be pulling that much current all the time. It's just, you know, the fuse has got to blow. A lot of the sockets, you know, will be rated for like 120 watt, you know, at the socket. So definitely wouldn't want to overload that. This thing's cooled down to the point where the hair's not really coming out all that warm anymore, and the fan's actually slowed down again. So surprisingly, nothing burned up. It held up. One little flaw though that I can kind of see with the way this thing cools, because the air comes out the bottom. So we've got these cutouts, so that's good. Like even if it's sitting flat, you know, you're still going to get airflow coming out of there. But if this thing's sitting in a cup holder that, say, is kind of sitting something like that, and it has like no way for the air underneath to, you know, kind of escape, all the warm air is going to be kind of like coming out, going upwards and going back in through the vents. So you're going to be just getting like a constant stream of warm air like circulating there. Although a lot of cup holders, you know, they're not that tall, so you might still be okay. You know, it's going to get some ventilation through there, so that's probably not going to be that big of a deal. And again, if you're only using like the USB ports and something like really low wattage on the outlet there, it's not going to be that big of a deal because it's not going to get that hot. Like I said, I ran it for several minutes with all this load, and the air was warm, but it wasn't like hot. The stuff coming out of the back of the PC usually feels warmer than that. So final thoughts on this: the board, the construction is really not that bad. The only complaints would be those MOSFETs that are kind of just there, nothing to really support them very well. The heat sinks on the other two MOSFETs, you know, where they could have used something, their own individual thing. The thin gauge wire going to the outlet, I think it might have been best, you know, if they would have used something a little bit thicker there. That could have been something to do with, you know, like limiting our wattage a little bit there, but I'm not exactly sure how much that actually had an effect on things. So not too bad of a design from what I could, you know, see. Just a few little minor things that, you know, if they were improved upon, it would probably be a lot better. I don't know how much this thing actually cost, so I couldn't really give you my opinion on that. But I do like the fact that it's got 4 individual USB ports, and each one is like labeled, you know, with what it can handle. The fact that this thing's not fully grounded, I've seen, you know, like other inverters where they do couple the ground like somehow, you know, to like the vehicle ground. This one had nothing at all. But I mean, if you're using stuff like small power supplies that, you know, really only have like 2 prongs, like say for like a portable game, you know, like say like a DS or something, then, you know, it's fine if it only has the 2, because those things don't have ground. Even some computer power supplies or like laptops, you know, they only have the 2 prongs. Alright, so yeah, that's pretty much gonna do it for this one. Let me know what you guys think about this thing. Give me your opinions. Thanks for watching once again. I will be seeing you guys around the bench.